first of all, thank you all for selecting this lightning talk and this work as the contribution, our community contribution award winner. I have the honor of getting to present this again for my team, who's listed on the slide here. And some of which are on the call. So Polina, Brian, Manlik, Andy, Ben, Mike, Tom, and Andrew. And what I'm going to talk about today is what we're proposing as the OMOP Waveform extension. So it's a way to integrate these physiologic signals and other associated derived features alongside the OMOP Common Data Model. It's analogous in many ways to the waveform extension, or sorry, the imaging extension, but we expand a little beyond that, and I'll talk about how and why we do so. In terms of content, provide a little bit of background on Bridge to AI and this kind of chorus grand pillar that I'm heavily involved in. A lot of this work was tailored for this project, and it'll become clear relatively quickly why. Talk a little bit about why we propose the extension, what sits behind it, why do we need it, and what types of data are we trying to capture, and then go into some detail about kind of a use case or set of use cases, let's say, and how those use cases can be represented within this extension and alongside OMOP. Drill down into each of those tables that I'm referring to in that use case, and then talk a little bit about next steps and make sure I acknowledge all of the pretty phenomenal people who made this extension happen. So I'll dive into it here. So bit of background, Bridge to AI is a broad NIH funded project that includes 4 pillars or 4 grand challenges, I guess I can call them. And they all kind of share this common theme of multimodality. So bringing multiple modes of health data, observational health data, into a kind of AI ready format. So let's build these data sets, make them publicly available for use within kind of AI paradigms. And Chorus is one of those grand challenges. And it specifically focuses on ICU data, so data collected in critical care settings across the modes that are listed at the bottom. So kind of your general EHR data, tabular stuff that we're representing in OMOP, together with radiology images and other imaging modalities. Some telemetry signals coming out of like bedside devices, so EKGs and pulse ox, but also EEGs. SDOH data, so looking at kind of spatially oriented and socioeconomic data, as well as just general operational and practice metadata about all of that. And I guess shouldn't be surprising that what I will talk about specifically with the waveform extension is this central one here, so the cardiac telemetry and EEG data that we're capturing. And so why do we need an extension for capturing these data? I think there's kind of 2 central motivations, and those are kind of central to a lot of the OMOP Common Data Model in general. So continuous time series data, or CTS data, which is kind of what I'm referring to in a lot of these different modes, they're diverse. So trying to do studies where you're looking at an EKG captured in one hospital versus one captured in another is a huge challenge. And so there's a strong need for standardizing not only the signals themselves, but also the metadata about those signals. And you have lots of different elements to capture in that. You have lots of different types of metadata, types of file formats, ways to record these signals, and underlying meanings. And so we want to essentially standardize that in the way that we're standardizing kind of diverse hospital EHR data into the OMOP Common Data Model. And then the second piece, which is I think equally important, is these data have a tremendous potential to provide insight. These are super rich data captured at many times per second in many cases. And they provide kind of instantaneous response to certain changes that happen to the patient while they're undergoing care. And of course, within Chorus, this is especially relevant in an ICU setting where somebody comes in and they're having a lot of procedures and a lot of drug things, lots of things are happening to them on a short time span. And so we want to be able to capture and understand the instantaneous effects of those particular clinical events. Okay, so kind of to paint a little picture of this, somebody comes into the ICU and they're put on a bedside monitor, and it has a 3-lead EKG, and maybe it has respiratory rate and pulse ox and some other things. And in your OMOP instance now, you might capture this as a device. This person was actually, this bedside device was used on this patient, and a procedure. Maybe you have something that maps the act of recording this kind of bedside measurement. And then you have maybe measurements that are coming out of your 3-lead EKG, or kind of some summary variables or whatever you might have. And where this is kind of where OMOP typically ends in a lot of cases, and what we proposed to do is extend beyond this. So we propose first a waveform occurrence, which captures this idea of recording a continuous time signal. And that could be an EKG, but it could also be an EEG or some sort of wearable device, together with waveform channel metadata. So each channel that's being captured during this recording, maybe it's one of the leads, maybe it's a respiratory rate or a pulse ox measurement, those all get their own associated metadata that give indications about how they were recorded and additional context. So sampling frequency and location on the body and things like this. And all of the files, and this I guess actually for chorus was very important, capturing all the various files and the segments and how they're kind of physically recorded. We're capturing using what we're calling the waveform registry. So keeping a register of all of these signals and how they're recorded and where they're located. And then the fun kind of begins, right, with feature extraction, a lot of this kind of maybe more machine learning oriented work where we're extracting features, we're running signal processing algorithms, and in many cases you're filtering the signals or interpolating them, and those kind of filtered or interpolated representations can again be saved and stored as a register file. And then the output of that feature extraction process can be placed in this waveform feature table, which is again analogous to the Note NLP table or the image feature table from the imaging extension. And that's where you have kind of all your derived values out of the signals. And I mentioned already in chorus, so we're doing this for EKG signals, but we're also doing it for EEGs. So many leads, looking at neurocritical settings, so like these neuro ICUs. And we're also starting to look at this, at least at Tufts, on wearable devices. So looking at signals coming out of a smartwatch or some other device, Holter monitors are similar like this, where you can then capture activity about a patient or insights about a patient outside of the care setting. And so the idea with this extension is that it's flexible to accommodate many different types of these kind of continuous waveform signals. Okay, so from kind of less granular to more granular, waveform occurrence is kind of our top level table. It's essentially saying something was recorded or captured. Gives in some context about what that recording was and when it started, and then a kind of a bucket of how many files were captured in that recording. The registry really catalogs those files, which, depending on your format of recording capture, can be very important. WFDB, for example, has header files and data files, and they all have to be in sync, and they contain different types of data about that recording. This also tells you when each file starts and ends, which is critical to analyzing it. The channel metadata I mentioned already captures information about each particular channel. So which lead was it? What was it actually recording? And then all the way down to the most granular, which is our feature table. And that's looking at things like QRS durations or particular peak heights or summary synopses of a particular signal. Okay, so that's the extension kind of in a nutshell. What are we doing next? I presented on a prior call and back at DevCon in April about this custom vocabulary builder. This allows people to create their own custom OMOP vocabularies as kind of a temporary solution while these things get uptaken by the vocabulary team. So we are finalizing now representations of these waveform particular concepts, and that includes kind of, let's say, all the way up to the domain level down to specific concepts representing particular features or particular leads or things that are not necessarily already represented in OMOP. Mentioned chorus, we're evaluating this waveform extension across 14 different sites at the moment, of which I think 4 or 5 have already put their data in this extension, and we're kind of running some different analytical paradigms on those data. And then the last bit is launching an OHDSI working group. We put together already some OKRs and an overview document that we're planning to propose. And I would love anybody who's interested in anything I just talked about, please come email me or reach out, and I would be happy to learn more and then kind of get you involved in some of the starting steps there. All right, and I guess I can wrap up here. This didn't happen in a vacuum. A lot of folks were involved in pushing this forward. So Jen and Paul at Johns Hopkins have been our kind of external reviewers, going back and forth with about the extension. These of course are key players in the imaging extension. Marty is essentially the glue that holds the Tufts team and also a lot of the chorus work together. All of you in the OHDSI community for feedback as well at the conference, together with Eric and the chorus consortium. And then again, a huge shout out to my co-authors, and specifically Andrew. This was kind of one of his visions, right? He had many visions of how he wanted things to go, but this was a key piece of kind of his view on multimodal data integration and being able to really harness all we can out of this observational health data set. So thank you very much. And I'd be happy to take any questions. I think, Craig, we're doing them now for 5 minutes. Perfect.
Yeah, you take a couple questions. I know Jared especially has to leave shortly, so just won't have time in the chat. So if you have any questions, maybe raise your hands, and then we'll move on to Luli next. Evan, go ahead.
Jared, thanks so much. Are you guys able to hear me?
Yes.
I'm just not in front of my computer, but really fascinating. I'm curious as to how you guys envision this interfacing with some of the OHDSI tool stack. Do we envision that tool stack will accommodate featureized, or things that have been featureized and in the waveform extension, or do you see it instead kind of having some kind of linkage to the observation table in ways that are maybe the stack works kind of out of the box?
Yeah, it's a great question. I mean, I think it would be a very big lift to get all of the tables and their content into the kind of the core OHDSI stack, at least in the short term. I think long term that would be, especially if it gets applied widely and it's used and there's a need for it. I think that's possible. I think at the moment there's a couple of answers to that. I think the first one is for GIS data and for this kind of external exposure data. I put together a vignette in the last couple of months showing how you can train a PLP model on let's say a non-OMOP table. This is based on a lot of awesome work in the custom feature engineering space over there. And so I think there's room for, if we look at like patient level predictions of the model developments, being able to custom incorporate a lot of the features coming out of the waveform extension tables. And then I think the second piece is we are developing some kind of cohorts that use, let's say, table references to these new tables. And I guess I don't want to take too much time on this, but we have some packages within Chorus that are starting to expand, being able to capture cohorts using metadata from these additional tables. And so I can post a link in the chat after this, but take a look at this Chorus AI GitHub organization. There's a lot of repositories, and I'll put link to one specifically that has some of our work doing some expansion of the kind of cohort capture and being able to use some of these metadata to include particular patients in a cohort or kind of augment cohorts that are based on the standard OMOP model. So hopefully that kind of answers your question, but we're heading in that direction, I should say.
I guess if I could,
it very much does. Thank you. It's great work.
Thank you.
If I could add to that, Jared, I think you touched on probably 2 places that we could learn from waveform extension that would go beyond just waveform. So fundamentally, you're either identifying patients, so that's like a core construction activity, or you're creating elements about patients, which is like a feature extraction activity. And if we can develop common solutions for how to handle extensions, that shouldn't be anything that's like specific to waveforms or imaging or anything else. It actually could be like, how do we accommodate extensions to the common data model that can support cohort building and feature extraction? So it'd be nice to for all of the extensions that are going on, I would presume that those are going to be like standard common problems that all extensions will face. So it's probably a really good opportunity for collaboration. And that is when you were commenting on like cohort definition, like, can you describe a little bit more about like how you guys are thinking about augmenting cohort definitions to use the extra data?
Yeah, it's a good question. So we've written some stuff to essentially further refine on top of an existing cohort definition. So we use kind of Atlas to create our first version of the cohorts, and then we pull out that first version. We add additional things based on our new tables. And so, yeah, I'll put a link in the chat to where some of this code is. But we have an R package that's working toward this because it's something that we've got a lot of requests from our analysts within Chorus. So, but happy to discuss that more in the future.